Hello friends, in this video, we'll learn how to create a setup process for a station object. And then we'll explore the Experiment Manager tool, which lets you run dozens or even hundreds of simulations to test different scenarios. This means you can test various input parameters and observe the results. In our example, we'll use the Experiment Manager to find the optimal size of this buffer. This means we'll run up to 100 experiments, each a separate simulation, where we change the capacity value to find its optimal setting. As always, you are free to use your own model from the previous lesson or download it from under the video. So, we start by showing how to create a process setup for the station object. In many companies, a setup is also called a changeover. We go to the Machine 1 class, and on the first tab, Time, we set the setup time to 5 minutes. Then we go to the second tab called Setup. Here we can activate Setup after Option, and we set it to after 100 parts. This means that after every 100 parts, this setup is performed, which takes 5 minutes. Now we go to the Experiment Manager object, but before that, let's remember that the buffer currently has its capacity set to 10. So, we will change the buffer capacity value using the Experiment Manager. We can find the Experiment Manager in the Tools tab, and we can insert it into the frame. In the Definition tab, we start by defining the output value. The output observation value is drain.numberIn. This is the number of parts we produce, because our goal is to set the capacity in a way that maximizes production. And of course, beyond a certain value, it doesn't make sense to keep increasing the capacity of the buffer. So we define the output values, and here we can simply drag and drop the drain directly into the list. We add numberIn, which shows how many parts went into the drain, and we select that higher values are better by setting it to true. That means the more we produce, the better it is. This helps us find the optimal value. And in our case, we also define the input values, which is the capacity of the buffer. We just add the buffer directly and write capacity. That's the name of its attribute. We set observations per experiment to 3. In our case, we're simulating with random numbers, which is why we use 3 observations per experiment. And now we go to the Tools tab and select Multi-Level Experimental Design. This means that here we define how the experiments and simulations should be configured. Here we set the minimum and maximum capacity value to be used for the buffer. So we set the lower level to 1 and the upper level to 100, meaning the minimum value is 1, the maximum value is 100, and the increment is 1. This means that after each experiment, it increases by 1. We click OK, and Plant Simulation informs us that it will now create 100 experiments. In each experiment, it increases the buffer capacity by 1. Each experiment is run 3 times. We reset the Experiment Manager when we are running it for the first time. And we can start the Experiment Manager. Now, over the course of a few seconds, a total of 300 simulations run in the background, since we have 3 observations for each of the 100 experiments. The experiment run is finished, and we can take a look at the results displayed in the Experiment Manager. It displays the results in the form of an HTML report. As we can see, increasing the buffer capacity leads to producing more parts. we see that the number keeps increasing until it reaches a peak at the experiment number 73. So in my case, I can see that increasing the buffer capacity beyond 73 is no longer beneficial, as it doesn't lead to producing more parts. We can say that the optimal buffer size in my case is 73, and with this capacity, I have produced 1,509.3 parts. Your results may vary slightly because we are using random numbers in the simulation. Here we can also see additional detailed statistics. The min-max diagram displays the range of minimum and maximum values of the observed output statistic. And this table provides detailed statistics for each experiment, including the mean value of the observed output, standard deviation, minimum and maximum values, as well as the confidence interval bounds, enabling precise comparison of the performance and variability of different simulation scenarios. In the last part of the report, we can see in the table that the maximum number of parts produced is 1,509.3, which is achieved with a buffer capacity of 73 or higher. We've reached the end of this lecture. In this video, we showed how to create the setup or changeover process for the station object, and then we demonstrated how to use the experiment manager to optimize the model. In our case, we were looking for the optimal buffer size. And as always, don't forget to save your simulation model, for example, as lecture followed by its number.